Okay, so this is video 3, part 3 of 2.8, and we're going to talk about Descartes' rule of signs. So I don't know if this is a review for you, or it's either review or reminder or new. So I told you that there was a rule that would help reduce choosing the P over Q's, so maybe you didn't have to do as many. So let's learn Descartes' rule of signs. Okay, so it was Descartes, René Descartes, that's how you say it. It's a French guy, so it's Descartes right here. It's a French philosopher and mathematician, and he discovered this in 1637, and it helps eliminate possible zeros from the lengthy list. But to understand how to do this, we've got to look at the variation in signs in a polynomial function. Okay? When a polynomial function is written in standard form, a variation of signs occurs when consecutive coefficients have opposite signs. So consecutive coefficients have opposite signs. It just means it changes from positive to negative or negative to positive. That's what that means, okay? So here's an example. How many variations in sign does the function below have? So this is positive, and then it goes negative, and then it's positive, positive, negative, negative. So from here to here is one variation. Negative to positive is 2. This is the same. This is different. There's the third one. And this is the same. So the answer would be 3. Okay, so that's how you do it. Now here's what his rule says. Given a polynomial function written in standard form with real coefficients, the number of positive real zeros is equal to the number of variations in signs of x, or less than that by an even number. And so if you have 3, if you get positive, if you get a 3 and you're checking for positive, you would say that it had 3 real zeros, 3 positive real zeros, or 1, because it has to go down by 2. So there's either 3 or 1 for this guy right here. 3 or 1 positive real zeros. Now, the number of negative real zeros, you have to substitute negative x in, and I'll show you a fast way to do that. If I were checking the negative ones, I'm going to rewrite it down here. 4x to the 5th minus 3x to the 4th plus 7x cubed plus x squared minus 6x minus 1. Okay, everywhere there's an odd degree, if I put a negative x in there, it would change the sign, right? So this would become a negative, all right? This is an even degree, so it would keep it the same, right? So this would be it's already a negative, so we're already looking at a negative, and that would keep it negative, so that's negative. This would change if I put a negative x in there, so from positive that would change to a negative. This term right here would stay the same because a negative x in there would keep it the same, and that's a positive, so that's still positive. And this one would be changed because it's going to be a negative x in there, so that would be from a negative to a positive. And then the last term would stay, there's nothing to substitute, so that would just be to a negative. So if you look, we have nothing here, nothing here. There's our first sign change. Nothing here, but we have another sign change. So this polynomial given right here has, if you're talking about positive real ones, 3 or 1 positive real root. If it has a negative, it has 2 or 0 negative ones. So that's how we can reduce it. So let's do a few so you can see some more examples. Okay, so for number 1, I'm going to do the positive ones first. So I'm going to check for positive real zeros. So here's a plus and a minus and a plus and a plus. I'm just getting the signs. So from here to here, there's 1. From here to here, there's 1. Okay, so that's 2. Oops, sorry. And from here to here, it's the same. So for positive, let me move this down because I got in the way. For positive, I have 2 or 0 roots. Well, I guess we're calling them zeros here. And they're just real zeros. 2 or 0 real positive real zeros. 2 or 0 positive real zeros. Okay, for the negative, I have to change the signs up a little bit. The first one, it would take it to a negative, and then it would keep it negative for the next term. I hope you're understanding. Look, 2x cubed. If I put an x in there, that would turn it negative, a negative x in there. The x squared would not change it. It still would be minus x. So minus x squared, it'd still be minus. The plus 2x would change it to minus, and the plus 1 would keep it plus. So I only have one sign change right here. So there's 1. So for negative real zeros, I have 1 real 0. Okay, so I'm not supposed to put a 1 there. I'm just trying to put, that's negatives. So here's how, like, you could write the answer. Positive real zeros, 2 or 0, and negative, sorry, I'm out of room here. I'll write it here. Negative real zeros, 1. Okay? So that's your answer. I'll try to write it neater on the next one. Okay, look at sign changes for the positive. This would be plus, minus, plus. So I have 1 here and 1 here. So 2. So positive real zeros, 2. Now, when I do the negative, when I stick negative x in here, it would become negative, stay negative, and plus 10 would keep it positive. So this would be no change and 1 change. So 1. So negative real zeros, 1. All right. Okay, let's do this one. Doing the positive one first, I would just do this. That is plus, plus, plus. So guess what? There's no sign changes, so positive real zeros is 0. None of them. None of them. And now, let's see. If I put a negative in here, this would be 2 negative x to the 4th plus 21 negative x cubed plus 27. I'm sort of showing you how to do that. So this stays the same. So this would still be positive. This would change to negative, and this would be positive. So I have a sign change here, and I have a sign change here. So negative real zeros would be 2 or 0. Last one. Okay, positive. I'm looking just at what I have. I have a plus, a minus, a plus, a minus, a minus, a plus. So from here to here I have 1. From here to here I have 1. So that's 2. From here to here I have 1. That's 3. Not 1 there, but 1 here. So I have 4. So for positive, I have 4, 2, or 0. Remember, you go all the way down by 2's. Now, switching signs, I would have negative x to the 5th, minus 2x to the 4th, minus 3x cubed minus 6x squared plus 4x plus 8. That's substituting negative x in for x. So that's a minus, 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 plus, plus. So I'm going to have one here, and that's it. So positive, oops, I'm on negative, sorry. Negative, real is zeros is 1. So that was 4, 2, or 0 for the positive, and only 1 for the negative. Okay? All right. I'm going to stop the video and do one last video for 2-8. So look for video number 4.